All right, so this is your last page of practice. I hope that you have practiced these on your own before me going over them. If you have questions on them, please let me know. I am happy to answer any questions that you have or your teacher. So, okay, so just remember, so we're sketching the graph of each function. Start out by finding your vertical asymptote. So in this case, your vertical asymptote is x equals 1. You're going to set what is inside of there equal to 0. So I always draw that first, so I know that my graph is either going to be on the right or on the left of it. And then what you're going to do is you're going to rewrite as an exponent. So here there's no base. So remember, if there's no base, it's an understood 10. The log is by itself. There's nothing added or subtracted or nothing in front of the log. So we're just going to rewrite that as 10 to the y equals x minus 1. So just go ahead and quickly pick a few points and see what it's going to look like. So in this case, I'm just going to quickly pick y equals 0. So when I plug in 0, 10 to the 0 equals x minus 1. 10 to the 0 is 1. And then that actually gives me x is equal to 2. Okay, so that gives me 2, 0. So I know that this graph is going to be on this side. It's going to follow, it's going to hug my vertical asymptote, and then it is going to go up and to the right. Okay, so that's what your first graph should look like. Now your second one over here, there's a little trick with it. What is that little trick? That little trick is the fact that you have this minus 5. So before you rewrite this as an exponent, you want to move that minus 5 over so there's nothing outside of this log. So it's going to be written as y minus 5 equals log of x minus 1. Okay, so what is our vertical asymptote here? And we're going to plug in whatever, make whatever is inside the parentheses equal to 0. So my vertical asymptote is x equals 1. Rewrite this as an exponent. Your understood base is 10 when it's not there. So 10 in parentheses, that whole thing becomes the exponent, y minus 5 equals what is left. That is your x minus 1. Okay, so this one's a little bit uglier here. So let's go ahead and draw our vertical asymptote. Okay, whenever we make our table here, okay, I always just start out by plugging in y equals 0, but in this case, that's going to be kind of ugly because 0 minus 5. Let's make this a nice, pretty exponent. Well, what value of y will make that work? Let's say 5, because if I plug in y is equal to 5, then that's actually going to give me an exponent of 0. So when I go to solve this, I would get 10 to the 0 equals x minus 1. 10 to the 0 is 1. And then if I add 1, that is going to give me 2 is equal to x. So I know I have the ordered pair 5, 2. Okay, and I know that this is going to follow my vertical asymptote, and it's going up and to the right. All right, so let's take a look at some of the questions at the bottom and see how you did with those. Now at the bottom, we're also going to identify the domain and range along with sketching our graph. Okay, so the first one right here, so we know that we have a vertical, let's find our vertical asymptote first, and that's going to help us find our domain and range. In this case, you're setting that equal to 0, so x is equal to -1. Okay, now your domain and range, remember your range is always going to be -infinity to infinity, so I don't really ever have to work for that. However, my domain is either going to be on the right or on the left. A hint here is if this x is positive, it's always going to be on the right hand side. If this x right here is negative, it's going to be on the left. Well, since it's positive, it's going to be on the right hand side. So that tells us that our domain is going to be -1 to infinity. So now since we know it's going to be on this side, now we just have to go ahead and graph it. Now the tricky part here with this one, once again, is notice this log is not alone. Okay, so what I have to do is I have to move that 2 over to the other side. So I end up with y minus 2 equals log base 5 of x plus 1. Now there's nothing next to the log. Since there's nothing out in front of the log or next to it, now I can rewrite it as an exponent. So I have 5 to the y minus 2 equals x plus 1. Now think about when you make your table here. Okay, I would pick values of y that are nice and pretty, so I'm actually going to pick y is equal to 2 because 2 minus 2 gives me 0. 5 to the 0 is 1. 1 minus 1 is going to give me 0. So that tells me that I have the ordered pair 0, 2. Okay, my graph's going to follow my vertical asymptote. Okay, and then I know it's going to go up and to the right. All right, so let's take a look at this next one right here. So this one right here, once again, same thing. You have to rearrange this to write it as an exponent, but let's actually do that next. So first thing let's do is let's find our vertical asymptote. Okay, we're going to set what's inside the parentheses equal to 0. So that makes our vertical asymptote x is equal to 1. I know my graph is either going to be on the right-hand side or the left-hand side. Since this x right here is positive, that means it's on the right. If it's negative, it's going to be on the left. Well, since that's positive, we know it's going to be on the right. So that tells us our domain is going to be 1 to infinity. And actually, that domain is going to help me pick correct values of x and y that are going to work. So my range is going to be, we know this is always the same, negative infinity to infinity. All right, so for this one to rewrite as an exponent, I have to move that -1 over so that that becomes y plus 1 equals log base 5 of x minus 1. Okay, because I don't want anything outside of my log. I want just my log to look like this. Now I can rewrite it. 5 to the y plus 1 equals x minus 1. So here, when I pick my ordered pairs, you can pick whatever you want. You can pick 0, whatever. 0 is not a bad choice for this one because if you pick 0, you end up with 5 to the first equals x minus 1, and then you end up with 6. So you have the ordered pair 6, 0. That actually gives you your x-intercept. Okay, so you know that it's going to follow your vertical asymptote and go up and to the right. All right, let's check our last two. Okay, so this one right here, number 5, what we're going to do is same thing. So let's first find our vertical asymptote by setting what's inside the parentheses equal to 0. So that's x equals -5. Draw your vertical asymptote and check and see. Number 1 is this x positive or negative? It's positive, so that means it's going to be to the right. So that tells us that our domain is going to be -5 to infinity, and our range is always exactly the same, -infinity to infinity. All right, so before we rewrite this one as an exponent, we need to move that -5 over so that it becomes y minus 5 equals log base 4 of x plus 5. Okay, now let's rewrite this as an exponent. So make sure you put this in parentheses because that whole thing becomes an exponent. 4 to the y minus 5 is equal to x plus 5. Now when I go ahead and make my table, once again, I kind of want to pick values that make my like a nice pretty exponent here. So right here, if I want this exponent to be 0, I'm actually going to pick a value of y to be 5 because I end up with 4 to the 5 minus 5 equals x plus 5. 4 to the 0 equals x plus 5. We know that 4 to the 0 is equal to 1. So 1 equals x plus 5, and x is equal to -4. That was a lot of solving right there. So I know I have the ordered pair -4, 5. All right, ladies and gents, I realized that I made a mistake here. So let's go ahead and fix this. Okay, this should actually say y plus 5 right here. All right, I needed you guys in class to tell me what I did wrong when I was working on this, so I apologize for that. Okay, so let's go ahead and fix this question now. I realized I was graphing it that it did not make sense. Okay, so actually we're going to choose y equals -5 instead of +5 in order to make this exponent equal to 0. So when I choose -5, I get 4 to the -5 plus 5 equals x plus 5. So I get 4 to the 0 equals x plus 5. And then I get 1 minus 5, and x is actually equal to -4. So that part didn't seem to change. But so we have the ordered pair -4, -5. Okay, and that graph is once again going to go up and to the right. All right, and then let's go ahead and take a look at our last one, but let's erase some of this other stuff that we got going on here. Okay, so our last one right here is a natural log. So let's just see what exactly that means. All right, number one, let's find our vertical asymptote. So we're going to set what's inside the parentheses equal to 0. So x is equal to 1. Then what we're going to do is we are going to get this natural log alone in order to graph it. But let's do our domain and range first. I got ahead of myself. Domain, first let's graph our vertical asymptote. Since this x is positive, it's going to be on the right instead of on the left. So I know my domain is 1 to infinity. And then I know my range is going to be -infinity to infinity. Okay, and now let's go ahead and graph it. So now let's rewrite it. Okay, so now let's go ahead and rewrite it. Remember, we want to get that natural log by itself, so you end up with y minus 1. I did that subtraction correctly this time, equals the natural log of x minus 1. So what is your base here? We have a natural log. Remember, a natural log is an understood base of e. So we're going to say e to the y minus 1 equals x minus 1. Now for this one, you're just going to have to estimate whether or not you're going to have to estimate your e. Remember, e is going to be about 2.71. All right, so let's just pick like a nice easy point here when we're picking y. I'm just going to pick y is equal to 1 because that's going to give me 1 minus 1 is 0. Okay, and that gives me e to the 0 equals x minus 1. E to the 0 is 1. And that gives me x is equal to 2. Okay, so now I have the ordered pair 2, 1, and I can go ahead and graph that. It's going to follow my vertical asymptote and go up and to the right. All right, if you have any questions, please let your teacher know.